Hi everyone. Here question is convert given NFA to DFA using subset construction method. We have seen two examples in the last two sessions where we had been given NFA state transition table, but in this question we have given state transition diagram. So what we will do, first we will convert this NFA state transition diagram to state transition table. Then using subset construction method, we will convert NFA table to DFA state transition table, and we know how to design or how to draw DFA or DFA diagram from the table itself. So here as diagram is given, first we need to convert it to NFA table. So how to convert diagram to table, that I have explained in one of the basic video, that the link is given above. For example, here are the three states Q0, Q1, Q2. So I will be writing here Q0, Q1, Q2. Remember that we are designing or we are writing here NFA state transition table from the given diagram. So how to write it? Q0, Q1, Q2. Here Q2 is the final state. Our input symbols are 0 and 1. So Q0 on reading 0 going to Q2. Q0 on reading 1, is there any transition for reading 1? No, so it will be 5. Q1 on reading 0, no transition for Q1 on reading 0, so it will be 5. Q1 on reading 1, it's going to Q0 as well as Q2. So I'll be writing here Q0 comma Q2. Then Q2 on reading 0 going to Q0 as well as going to Q1. There are two transitions from Q2 for symbol 0. So Q0 comma Q1. Similarly, Q2 on reading 1 going to Q0. So this is what NFA table from the NFA diagram. Now from this NFA state transition table, we can draw or we can find out DFA state transition table using subset method. How to write it? For example, we will be utilizing this NFA state transition table. For example, first row as it is, Q0 will be our first subset as a starting state. So this is a subset notation. Our input symbols are same, 0, 1. So Q0 on reading 0 going to Q2. So Q2 will be our first subset. Q0 on 1 going to 5. So 5 is as it is. So in this case, you can write 5. Or you can also write down a dead state. Both are allowed. Here new subsets are created. Q2 is a new subset. So I am writing here Q2. Q2 on reading 0. See Q2 on reading 0 going to two states Q0 comma Q1 in the NFA diagram or NFA table. But deterministic property says that one state reading one symbol should go to only one state. But NFA, these are the two states. So subset method says that create the subset. How? It's very simple. Q2 on reading 0 going to Q0 comma Q1. Combine these two. Now you will be wondering how to combine the two states. I am only combining the name of the states and this becomes your new state. This subset or this state Q0 Q1, this is not two state. This is the only one state. If you want, I can show you like this. Q0 Q1. In the diagram notation, this is the only one state. Similarly, Q2 reading 1 going to Q0. So I am writing here Q0 as a subset. Now, which are the new subsets created? Q0 Q1 and also Q0. No, Q0 is already covered here. So Q0 Q1 is a new subset. So I am writing here Q0 Q1. This is a new subset. Q0 Q1 reading 0. How to find transition for this? Q0 Q1 reading 0. So Q0 on reading 0 going to Q2. Then next one is Q1 reading 0 going to 5. So combine this Q2 null union is Q2 only. So Q0 Q1 reading 0 going to Q2. Q0 Q1 reading 1. So Q0 reading 1 5. Q1 reading 1 Q0 comma Q2 going to two states in the NFA. But in DFA only one state. So Q1 reading 1 going to Q0 comma Q2. If I want to combine these two, how to combine 5 union Q0 union Q2? So it becomes Q0 Q2 and it becomes one subset. In the NFA, these are the two states In the DFA, it's only one state. For example, when you draw the diagram, it will be considered as only one state, Q0, Q2. What are the new subset? Q2 is covered in the second row. Q0, Q2, this is a new subset. So I'm writing here Q0, Q2. How to find transition? Same process. Refer the NFA table. Q0, Q2. So Q0 on 0 going to Q2. I'm just completing this. It's going to Q0 and Q0 on 0 going to Q2. So here is Q0, Q2, Q0 on 0 going to Q2, this one, but Q2 on 0 going to Q0, Q1. So we can combine this Q2 plus Q0, Q1. As here are the two states, Q0, Q2. It's our one subset, but in the NFA two states, Q0 and Q2. So combine this Q2, Q0, Q1. Sequentially we can write down Q0, Q1, Q2. So this is our new subset. Similarly for transition for 1, Q0 on 1, nothing. Q2 on 1, it's a Q0. So it's a Q0 only. Q0, phi, union is Q0. Is there any new subset created? Yes, we have the new subset. What is that? It's a Q0, Q1, Q2. So we can repeat the process for it. So process is find out transition for 0 and 1 for Q0, Q1, Q2. Now you can find it out. It's very simple. In the NFA table, Q0, Q1, Q2 are different states. In the DFA table, it's the same state, Q0, Q1, Q2. So combine this. Q0 on 0 going to Q2, Q1 on 0 going to phi, Q2 on 0 going to Q0, Q1. So combine all this. It becomes Q0, Q1, Q2. Sequentially we can write down as a one subset. Again, in the NFA table, Q0, Q1, Q2, these are the different state, but in the DFA table, this is the only one state, Q0, Q1, Q2. Similarly, Q0, Q1, Q2 on reading 1, where it will go? Combination of all this, because here Q0, Q1, Q2 are different states. Here it's only one state. Combine this phi and combination of this Q0, Q2, Q0. So here Q0, Q2. Is there any new subset here? Q0, Q1, Q2 is covered. Q0, Q2 is also covered. So there is no new subset, and this becomes our DFA state transition table. And we know how to convert DFA state transition table to diagram. For that we should know starting state. Starting state is Q0 here. In our NFA, final state is Q2. This is a final state. So wherever in the row headers Q2 is present, that state becomes final state. Here is a Q2, so Q2 becomes final state. Q0, Q2 contains Q2, so Q0, Q2 becomes final state. Here also Q2 present, so this becomes final state. So there are 3 final states, total states are 5, and from this DFA state transition table, you can draw the DFA diagram. If you don't know how to draw the diagram from the table, you can watch the above video. I have explained separately how to draw the diagram from the table or from diagram to table. You can have watch on it. So this is our final answer. Thank you for watching.